Okay, I just wanted to do this quick video on the standard algorithm, 2 by 2 digit multiplication, because I know that the book and the video that's part of Eureka, they show it a little bit different than growing up I saw, and how still most of us traditionally do the standard algorithm of multiplication. So I'm going to show you here, if we're multiplying 36, why that's doing that, 36 times 40, we'll do 45, okay? So if I'm doing 36 times 45, how am I going to multiply this? Well, I'm going to set it up and do 36 times 45, okay? I'm going to start in my ones place. I like to start on the bottom number. Doesn't make a difference which order we multiply them based on the commutative property of multiplication, but I'm going to start on the bottom, and I'm going to start with my 5. And I'm going to do 5 times 6, okay? So 5 times 6 is 30. I'm carrying the 3 over and putting the 0 down here. So what I've just done is I've done 5 times 6, okay? Now, after I do my 5 times 6, I'm still using that 5 because I have to multiply it by that 3. 5 times 3. What is 5 times 3? 5 times 3 is 15, okay? 5 times 3 is 15, and I'm adding the 3 more. So that's going to be 18, okay? Now I'm done with that 3. I'm going to cross it out. And now I've multiplied 5 times 3. It's like a turtle head, okay? I know in 3rd grade you may have talked about turtle heading your numbers, okay? So I did my 5 times 3 already, okay? Now I need to go to the next row, okay? I'm going to the next row underneath our 180, okay? Because that is our first, that's our first partial product here, okay? Now, for me to go underneath that 180, because I am now moving to the 4 here, which is really worth 40, and now I'm going to multiply that 4 by everything, all right? What I have to do is I have to put a 0 as my placeholder, okay? I'm putting that 0 there because I'm really multiplying by 40, okay? Although I'm just going to say 4, okay? I'm doing 4 times 6, but since I know it's really 40 times 6, that's why I'm putting that placeholder. That is an absolute must, okay? So 4 times 6 is 24, all right? I'm putting the 2 on top of my next column, all right, of the number I'm multiplying, and then I put the 4 down low in my next row, okay? Now, I do 4 times 3, which is 12. Add that 2. Don't forget to add the 2, the number that you carried over, which would be 14, okay? Now, I'm adding because this is now my second partial product. Okay? And now let me add. 0 plus 0 is 0. 8 plus 4 is 12. Carry the 1. 4 and 1 is 5, and 1 is 6, and nothing in 1 is 1. So your answer is 1,620. Okay, let's make that. All right, that is 36 times 45. All right. Now you will see in your book, it's showing the standard algorithm with the same numbers, right? But it's dragging out. It's dragging out the problem even more than I think it needs to be. I'm going to show you right here. what it's doing is, and I'm going to continue with my 36. Ready? I'm going to do my 36 and my 45. It's going through all the steps again. It's going to say here, like we did 5 times 6, it's going to say 5 ones times 6 ones equals. All right? Then it's going to go 5 times 3, which is really 5 ones times 3 tens equals. Then now it's moving over to the 4. All right? And that's really 4 tens. So it's going to do 4 tens times 6 ones. And it's going to do 4 tens times 3 tens. Now, watch. Let's get the product of each of these. 5 ones times 6 ones is 30 ones. 5 ones times 3 tens, right? 3 tens is 30. 30 times 5 is 150. 4 tens times 6 ones is 40 times 6 is 240. And 4 tens times 3 tens is 40 times 30 is 1200. Let's add up 1200, 240, 150, and 30. Add up my whole right column is 0, and then 4 plus 5 is 9. 9 plus 3 is 12. Carry the 1. 1 and 2 is 3, and 2 is 5, and 1 is 6. And then we just had 1. 1,620. That's how the book is showing standard algorithm. Okay? Really, if you could just do the standard algorithm the way that we have been doing for years and years, that will get you the correct answer. But this is how the book is showing you. It's walking you through each step. That is the standard algorithm for 2x2